This is on linear inequalities. So linear inequalities, the way that we're going to write them in Algebra 1 is using something called interval notation. So many of you guys probably have not seen interval notation. It's just kind of a shorthand way of writing like x is less than 3 and so on. So it says interval notation is a way of writing all of the real numbers between two endpoints. So if you have a bracket, so this kind, or this kind, they're used when we include an endpoint of an interval, and then so the brackets are going to include the endpoint. It's like it's filled in on that endpoint, and then the parentheses are going to be open, okay? So I have some examples. So the first one, we have the number line, and we have 0 and 4, and notice how 0 and 4 are not filled in. That means they are not part of the answer, so we do not include them in our answer. So our inequality would look like 0 is less than x, which is less than 4. So what that means is all numbers that are, the number is greater than 0, but also less than 4. That's how we write it. Have you guys seen that before? Okay, so that's the way you'd write it with inequalities. And then interval notation would be, we want to include everything between the left endpoint and the right endpoint. So between 0 and 4, so we write it like this. So we do 0, 4, parenthesis. And what that means is it's including everything between there. It's not a point, like you know how points we like graph as 1, 3, like over 1 up 3. It's not a point, it's an interval.
So
okay?
It's like showing the distance between?
Yeah, it's saying include all values. So like I would include 2.713 in there, okay? Everything that's between 0 and 4 would be included in our solution. Okay, so what if I have 0 and 4 like that, but I don't include 0, I do include 4, then it would be 0 is less than x, which is less than or equal to 4. Do you guys see why I have the equal to 4? Because the 4 is filled in. Okay, so with interval notation, it would look very similar. We'd still have a parenthesis on the 0, but we'd have 4, and then it would be a bracket. Okay, so this bracket means that we include 4. So 4 has been shaded as well.
So what is it when the dots are filled in versus not filled in?
When it's filled in, that means that it's part of our solution set. Okay, so we'll do some examples. It's basically an answer as well. All right, so the next one, what do we think this one would be? So we're going to have 0 is less than or equal to x, which is less than 4. And interval notation, what would we put? So let's see, Max, how about you? What do you think? Got any guesses? Yeah, so it would be a bracket on the first one, right? So a bracket on the 0 and then a parenthesis on the 4. Do you guys see it? So I always tell my students that I remember the bracket is kind of like a big equal sign. So think about the top and bottom as being part of an equal sign. So it's including the equal. All right, so the next one would be same idea. 0 is less than or equal to x, which is less than or equal to 4. And we would write it as bracket 0 to 4 bracket. Okay, so what if we don't have an endpoint? So this one's going all the way off on the far left. Okay, so what's the smallest number? Where do we start? I don't know. Is there a smallest number? There's not. It goes on forever. So what is the biggest negative number you can think of?
Just use x.
No, not x. Negative infinity, right? That's as big as it can possibly be. So it's going to be, for the inequality, we actually just say x, yeah, that's what you were saying, Maya, right? X is less than 4 is the inequality. But for interval notation, we want to indicate that it goes off forever in this direction. We're reading it like a book left to right, and we're saying, oh, on the left-hand side, we include all of those big negative numbers. So we write it like this, negative infinity to 4, parenthesis. All right, so we read it like a book, all the numbers from the left to the right. And then this next one would be x values that are greater than or equal to 4. And this one's going to look like, if I read it like from a book left to right, 4, comma, infinity, like that. Notice how the 4 has a bracket, infinity does not. Anybody have any guesses about infinity? It is a big number. Do you think we're going to put brackets on it or parentheses on it? Parentheses, because what I did on those last two, right? Infinities will always have parentheses. Always use parentheses for infinities.
My geometry teacher said when you have one like bottom one and the second last one, you put the less than greater than sign pointing where the arrow is.
Yeah, exactly. So do you guys see what he's saying? Well, let me talk about the infinities first. So we always put a parenthesis on the infinity because we never equal infinity. We never get there, okay? So have you guys ever, I don't know if you have siblings. I have, like I was telling Dakota, I have a twin brother, and we would always be very mean to each other growing up, and we would always have that argument where it's like, I hate you times infinity. I hate you times infinity plus 1. Right? There's never any end to that argument. You never had that argument? Was yours like, I love you times infinity. I love you times infinity plus 1. I don't know. My brother and I were not nice to each other growing up, but we are very nice to each other now. Okay, so we always use infinity. Infinities will always have parentheses. We never equal. Shh, guys, we never equal infinity, okay? Now, the other thing that AJ is talking about is he says his teacher always told him to put the x, like these right here, to put the x on the left-hand side, and then the arrow points in the direction that you want to go. So see how this says less than and this is greater than? It looks like little arrows. Okay, so you can remember that as well. Okay, so as long as the x is on the left, you just shade in that direction. All right, so let's do some examples. So it says graph each set on a number line and use interval notation to represent each set of numbers. So now we have it in the what do we call it? In the inequality form, and we want to write it in interval notation. So let's graph these on a number line. So we're going to have 2 is less than x, which is less than 3. Will, you with me? All right, so it's going to be directly in between 2 and 3. Okay, so think about how we would write this. Sarkis, what do we have?
Okay. I'm reading it.
Take that off your face, please.
Graph each set on a number line. Okay.
So it's going to be like that, right? 2 to 3 with parentheses on it. Okay, so the next one, we have -3 to 4. Okay, so we're including everything between there. So it's saying -3 is less than our number, but our number is less than 4, right? So you're like that. All right, so it's going to be bracket -3 to 4, parentheses. Do we all have that? You get it? Now sometimes we have what's called compound inequalities. This next one is a compound inequality. All right, so it's going to say that x values are greater than or equal to 4, or our x values can be less than -2. Okay, so this one has 2 things. Okay, so if I was talking about the left-hand one, and I'm reading it like a book from left to right, I start way down there at negative infinity. So I go negative infinity to -2. Okay, so that's how I'd write just the left-hand one, negative infinity to -2. Does the -2 have a parenthesis or a bracket? Cam, what do you think? Parenthesis or bracket? -2, parenthesis or bracket? Parenthesis, right? And then the right-hand one is going to look like bracket 4 to infinity, like that. Now we want to indicate that both of these are part of our full solution, right? These go together. This is part of our one answer. Okay, so what we do is in between them we put a little u, a union. Now that u does not have a stem. It's not like that. It is just a u like this. So it's a certain math symbol. It means
so how do
union.
You know when to use the parentheses and not? If it's like negative, use the.
If it's equal to, so if it's filled in, we use the bracket. If it's open, so not filled in, then we use the parentheses. Okay, infinities always have parentheses. All right, so a U stands for union, and it's used when we use the word or. So if we have 2 pieces, if it's like, oh, we could be over here or we could be over here, these numbers would all work. Then we put a union between them. All right, so what if we have the graph? So all of these have the graphs. So number 1, its interval notation has 2 pieces. It's going to be the kind that has a U between it. So think about how you would write it. Do you guys want to try first? I'm going to try to write it. The left-hand side would be negative infinity to -2, parenthesis. The right-hand side is 5 to infinity, parenthesis. And we put a U between it. Sarkis, I'm not kidding. Stop. Number 2. So as we read it like a book, left to right, the first thing that we hit is -2. So we do bracket -2. The last thing we hit is 5, parenthesis. Number 3, we have negative infinity to -2 with a bracket. And then the other side is going to be parenthesis 5 to infinity with a union between those 2. Do you guys understand this? You get it? Okay. And the very last one, what do we write on this one? So Tessa, do you got it? like a book.
The bracket and then -2
Uh-huh.
and then 5.
And then bracket. Yep, perfect. Okay, so -2 to 5, both in brackets. Everybody has this down? All right, so this is how we will be writing our final solutions when we solve an inequality. So inequalities are going to be just like equations, except some of them are going to have less than, some are going to have greater than. So we're going to have a whole bunch of numbers as our solution, not just a single answer. So it says an inequality is a statement that compares two expressions by using less than or equal to, greater than or equal to, less than or greater than. Okay, so when we multiply or divide inequalities by a positive number, the inequality sign stays the same. So let me show you an example. So let's start with just numbers. We won't have any x's here. So what if I had 2 is less than 3? Do we agree 2 is less than 3? Yes, 2 is less than 3. Remember, the alligator wants to eat the bigger number. We talked about this before. All right, so what if I multiply by the same positive number on both sides? What if I multiply by 4 and multiply by 4? What would my new inequality be?
8 is less than 12.
Okay, is that true? Is 8 less than 12? Yeah, so the inequality sign, it was less than before and it stayed less than now. Okay, but if you multiply or divide by a negative number, then your inequality sign switches or flips. Let's use the word flips. I think you guys know what that means. All right, so it's going to flip around. So let's do another one. So let's say 4 is less than 5. What if we multiply through by a -2? Then we get -8 and we get -10. So let's think about it. If I was doing a number line, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. I should have chosen a smaller number, right? Is -10 bigger or smaller than -8?
Smaller.
Yeah, -10 is smaller, right? So when we say -8 and then we have something and we say -10, we say -8 is bigger than -10. Does that make sense? So what happened in order to make that true, we had to flip our sign. So we flipped it. Okay, do we all understand that? Sarkis, go sit over there. Okay, we'll throw it away and then go sit over there. All right, so it says solve the following inequalities, graph the solution set on a number line, and write your solution in interval notation. All right, so I have 4x is less than 1. So just like if I had 4x equals 1, in order to solve for x, we would divide by 4 on both sides of the equation, right? That's what we're going to do here. So we're going to divide by 4 and divide by 4. Okay, since I'm dividing by a positive number, I don't have to flip the sign. Okay, so I do x is less than 1/4. It's just like that. Now, when you write your number line, I don't really worry about putting all the different tick marks. A lot of Algebra 1 teachers and pre-algebra teachers are really concerned with, like, don't do this, but putting 0, 1, 2, and then saying, oh, 1/4 is right here. It's going to be everything smaller than that. I don't care. Like, you can do those little tick marks if you want to. But the way that I typically do it is I just put 1/4 on my number line, and then I do a little open circle, and I say, oh, I have everything on the left of that, everything that's less than 1/4. So it looks like that. Sometimes people get very fancy with graphing too. Like some books, I think your book does this, does like a little parenthesis here and then goes this way. And notice how they put it a little bit above the line so you can see it. If you want to write it that way, you can do that as well. I personally like the open circles and closed circles. That's what I grew up with. All right, so if I was writing this in interval notation, we read it like a book left to right. So it would be -infinity to 1/4, and we don't include 1/4, so we do our parentheses. That is our final solution set. So what does this mean? Any number over here works in the original. So if I plug in 0, does it work? 4 times 0 is 0. Is that less than 1? Yeah, if I plug in like -1, -4 is less than 1, right? Any number in here will work in our solution.
So do you just divide by the largest number in the set, or?
No, it's just like if we had 4x equals 1, right? How do we solve that equation? We divide by 4. We want to get the x by itself. Get the x by itself, yeah. So this next one, so we're solving it just like it's an equation. So I'm subtracting 5, subtracting 5. I have -2x is greater than or equal to 2. I'm dividing by -2. When I divide or multiply by a negative number, that's when it's important. I always call this the red flag rule. So I'm drawing a little red flag. So what do I have to do? When I solve, it's not x is greater than or equal to negative 1, it's x is less than or equal to negative 1. So you have to flip that sign. So x is less than or equal to negative 1. We have everything on the left of negative 1. Ryan, Will, you guys good? Got it? So our answer is going to be negative infinity to negative 1 bracket. Okay, that's our answer. Easy enough. Can you guys handle these? So obviously, just like with equations, it gets harder. Like equations, I gave you some really hard ones with decimals, fractions, and so on. You could have decimals, fractions with inequalities as well. All right, so this next one. So it doesn't matter which side you get the y's on. Let's say I subtract my 8y over like we did with equations so that we have a positive number. So we'd have 6 is less than 4y minus 18. And then we add our 18 to both sides. So we get 24 is less than 4y. And we divide by 4, divide by 4. So we get 6 is less than y. Okay, notice I did not change, like I didn't put the y over here and then the 6 over here. Like a lot of times with equations, you can just say like, oh, y equals 6, and just like move the y over, like switch their sides. I don't do that with inequalities. But I can at the very end. So if I have 6 is less than some number, right? 6 is less than y. If I wanted to write the y on the left-hand side, how would I write it? Brian, you got it? No? Cameron?
Y is greater than, or
Y is greater than 6, right? So it kind of goes back to that alligator thing. Like the alligator wants to eat the bigger number, right? That's how you guys learned it in elementary school, I'm sure. So like the alligator's mouth goes with Y, well the alligator's mouth is still going to go with Y when you rewrite it. Does that make sense? So saying 6 is smaller than Y is the same as Y is bigger than 6. And the convenience of doing that is exactly why what AJ was talking about at the beginning. Okay, so if we write the variable on the left, then when I put 6 in, it's going to point in the direction that I want it to point in the end. So it's saying everything on the right of 6. Does that make sense? All right, so we would write our final answer as parentheses 6 to infinity, like that. Okay, so you guys don't have to do this, but go ahead and pay attention if I had done it the other way. So if I had 8y plus 6 is less than 12y minus 18. Minus 18. Okay, so let's say I had subtracted the 12y over, so everybody look up here. You don't have to do it. Then I'd have negative 4y plus 6 is less than negative 18. I would then subtract the 6. So I'd have negative 4y is less than negative 24. And then I would have to divide by that negative 4, which is that red flag rule that I was talking about. That's like, oh, I have to divide by a negative, so I have to flip my sign. So we get y is greater than 6. Okay, so you can get things on the left-hand side, like see what the difference was. The first thing I did on the original was I subtracted 8y, subtracted 8y. Now I subtracted 12y and 12y. But just don't forget when you get to this point right here, you're dividing by a negative. Okay? So you have to flip your sign. So you could do it either way. A lot of people get kind of stuck like, wait, which side should I do it? Should I have the positives x's or should I have a negative but on the left side? Like what's the best way? It doesn't matter. All right, so let's try these last ones. So do you guys want to try 5 and 6 first?
Wait, so when's the test?
It will probably be like right when we get back from fall break. Not the first day, but probably the second day back. Okay, so go ahead and try these. First, distribute the negative 2n. So you should have negative 2y minus 8 is less than or equal to, and distribute the 2n as well. So you're going to have 2y is minus 2, like that. Which side did you take the y's on? Did you put them on the left side or the right side?
The right side?
The right side, so you added 2y to both sides. So you get negative 8 is less than or equal to 4y minus 2. And then we add 2, so we get negative 6 is less than or equal to 4y. We divide by 4, so we have negative 6 over 4. That reduces to negative 3 over 2 is less than or equal to y. Now, if you want the y to be on the left-hand side, see the arrow points the way you should shade? If you say negative 3 over 2 is smaller than y, then that means y is bigger than negative 3 over 2, right? So if your teacher, your teacher was really picky, I'm not picky, you would have to know where negative 3 over 2 is. Okay, so let's think about this. 3 over 2, where should that be? It's 1 and 1/2, right? So it's 1.5. Does that make sense? Because it's 3 over 2 is the same as 1 and 1/2. So 3 over 2, if you were graphing it, it would be like right here. Do you guys see? So you'd have everything bigger than that. Now, I don't care about all those tick marks, so I'm fine if you guys do negative 3 over 2 and then do everything that's bigger than it, like that. That's totally fine with me. So our answer should be bracket negative 3 over 2 to infinity. Oops, that's a parenthesis. It doesn't really look like a parenthesis. Okay, are we understanding that? Did everybody get that answer? Good. All right, so this next one, so I have 1/2 x minus 5 is less than negative 3. If I add the 5 over, I get 1/2 x is less than 2. So we've talked about this before. If I had an equation and I said half of some number equals 2, you guys know it. You can do this without doing any operations. Half of what number gives you 2? 4, right? Does that make sense? Half of what number gives you 2? 4. So what we do to both sides to get rid of a 1/2 is we multiply by 2 on both sides. Okay, so I'm going to get x is less than 4, like that. All right, we didn't have to switch our signs or anything because we had a positive number that we were multiplying. So we have an open circle on 4, everything on the left of it. So our answer should be negative infinity to 4 parentheses. Okay, and that's it. Did we get that one too? All right, so let's try these harder ones. So on number 7, we have everything all together. Okay, so it's negative 6 is less than or equal to 2x plus 4, which is less than or equal to 10. Okay, so we could break this apart into 2 separate. So could break into negative 6 is less than or equal to 2x plus 4, and then 2x plus 4 is less than or equal to 10. Do you guys see how I got that? So I took the left 2 together, and then I took the right 2 together. Okay, so you could do that. But really, I don't ever do that unless I had like x's in all 3 like locations or 2 of the locations. Do you guys see? Do you see where the x is? It's only in the middle. So if the x is only in the middle, just keep it all together. But if x is only in the middle, keep the inequality as is. Okay, so as it is. So we're going to keep it as that negative 6 is less than or equal to 2x plus 4 is less than or equal to 10. Has anybody ever done these before? Do you know what this is? Yeah, these ones are weird ones. So this is why we were going to practice this tomorrow, because I was like, I don't know how much of this like compound inequality stuff they've done. So we'll do a couple in the examples and we'll do more tomorrow. All right, so what we do is we try to isolate the x on the inside. So if I was trying to get the x by itself, I have to get rid of that 4, right? So what do? I subtract 4. But I'm going to subtract it from all 3 locations. So I'm going to subtract 4, subtract 4, subtract 4, and then write the new answer. Okay, so now I have negative 10 is less than or equal to 2x, which is less than or equal to 6. Now what? Get the x by itself, so we do what? Yeah? Not subtract 2. What's the sign between? It's multiplication, so we divide by 2, right? So divide by 2, divide by 2, divide by 2. So we have negative 5 is less than or equal to x, which is less than or equal to 6. Oh, 3. Thank you. Oh, Maya gets bonus point. All right, so now we want to graph that. So the way that this is read is negative 5 is smaller than some number, but that number is smaller than 3. So on a number line, we have negative 5 and we have 3. And we have everything that's in between it. Do you see how x is sandwiched between the 2 numbers? So our shading is sandwiched between those 2 numbers. So we're going to have less than or equal to, like that. So negative 5 is less than or equal to x, which is less than or equal to 3. It's going to be the shading in between. So our answer then would be bracket negative 5 to 3. Okay. So what we just did is what we would call an and statement. So when I said we break into these 2, this is an invisible and between it. You can see I wrote and. It's like this is true, but also this is true. The 2 things both have to be true, and it ends up being like overlapping in the middle. But if you have an or statement, they could go in opposite directions. You could have something on the right, something on the left. Colin. So this one is an or statement. So a lot of times the or statements will go in opposite directions. Okay, but not all the time, but a lot of times they will. So let's try this one. So I'm going to subtract the 4, subtract the 4. So I get negative 2x is less than 2. I divide by negative 2, red flag rule. Right, so we flip that sign, so it's going to be greater than. So I get x is greater than negative 1, like that. Now this other side, I subtract my 8, I get negative 3x is greater than 3. I divide by negative 3, I divide by negative 3. I get x is less than negative 1. I didn't realize I did this. I made them both negative 1, didn't I? So if we have x is bigger than negative 1, or x is less than negative 1, then we have either side of that inequality. Okay, so if I pick a number, like 2. 2 works in one of those. It works in this first one, right? If I plug in 2, negative 4 plus 4 is 0, 0 is less than 6, it works. Okay? But if I pick something on this side, like negative 3. Negative 3 times negative 3 is 9, 9 plus 8 is 17, 17 is greater than 11. It works there. Right? So every single number works on the number line except for what number? What number is bad? Is there a number I don't have shaded? It's tricky. The only number that's not shaded is right here. It's not shaded, so we have to keep that off. So it's every single number except for negative 1. So the way we write it is negative infinity to negative 1, parentheses, union, negative 1 to infinity. Okay, so it skips over negative 1. Okay, we need to do another one because that was kind of weird. All right, so let's say we have number 9. So you can add number 9 on the end if you have room. If you don't, that's fine. Just put it on blank paper. Or just pay attention. All right, so let's say we have 2x plus 5 is greater than 7. And we have x minus 3 is less than negative 2. Okay, and this has an or between it. So or statements could be 2 separate sides of the inequality. Like they don't have to be connected together. So if we have this, we subtract our 5 over. So I get 2x is greater than 2. And I divide it out, and I get x is greater than 1. But this other one, if I add, dang it, I did it again. Let's make that x plus 3. I subtract the 3 over, get negative 5. So that means x is greater than 1 or x is less than negative 5. So on a number line, what it will look like is we'll have the negative 5, we'll have everything below it, and then we'll have the 1, and we'll have everything above it. And we have 2 separate pieces. Don't pack up. So we're going to get negative infinity to negative 5, parentheses, union 1 to infinity, like that. So it would be 2 separate pieces. So we'll do more of the compound ones tomorrow. But